Hello, good evening, Professor. Today we'll be discussing the assignment Lab 3 of COM 380. So let's begin with the question 1. What does it mean for an arc to be consistent? If a binary constraint C containing variables x and y, x is arc consistent with y if for every value x in the domain of x variable there should be some value y in the domain of y variable such that combination of values x and y satisfied the constraint C. And so basically it means that there should be at least one value in x variables domain uh, which is consistent with at least one value consistent and satisfies the constraint with at least one value in the domain of variable y, then it is arc consistent. What does it mean for a network to be arc consistent? It basically means that a network is arc consistent if uh, if every node or variable has consistent assignments with its neighbors. So for each neighboring variable the arc is consistent, then the whole network is considered consistent. What are possible outcomes of consistency algorithms? There are four possible outcomes of consistency algorithms. The first one is that we end up with a consistent graph after pruning of values from the variable domains. If there are still possible values left in which all constraints are satisfied, then we are left with an arc consistent graph. And second, the arc consistent graph does not guarantees a solution. There might still be a solution or might still not be a solution, as we'll see further, but will for sure end up with a graph which is arc consistent. The second possible outcome is that we end up with an infeasible graph. In that case, there is a possibility that after running the pruning process there is no values left, which would mean that the CSP is infeasible and there are no possible solutions to this constraint satisfaction problem. And then the third question is partially consistent graph. An arc consistency might also lead to partially consistent graph where some variables have only one value left in their domain but others have more than one. In this case we have to use some other values which can narrow the solution space down to find the solution. And the fourth is there is no change, because if the graph is already consistent then there will be no change as it is already consistent. Now let's look at question 2 and see this problem in AI space as well. So the D part of this question asks, consider the CSP below. If you run the consistency on this CSP, will there be domains of any variable get smaller? Okay, so here, if as you can see, the the constraint is that A should not be equal to B. So for a value in the domain of A, let's take true, there should be at least one value in B which is not equal to true, and that in that case there for sure is a value which is false. And same for false, you can see there is a value true in B. And similarly, if we go through all of these uh, in C case also and in A to C case also, there exists a value. There should be only one value which satisfies, so there exists a value which satisfies the constraint. So this graph is already arc consistent and will not be having any change, which is one of the possibilities that we discussed earlier. This is my prediction. If arc consistent finishes, all the variables are multiple. Okay, so as the domain is left with multiple values, there might or might not be a solution. It just means that graph is now arc consistent. We can use other algorithms to find the solution further. Okay, now I've already created the graph in the CSP. Let's see. As you can see, the domain is still the same for every node. Therefore, our predictions were correct.